Hello students, and welcome to the CompTIA Tech Plus exam course brought to you by Third Level Technology. I am your instructor, Jim Herby. In this episode, we're going to continue in Module 2 in the exam objectives by discussing Section 2.8. Our topic is Networking Basics. Let's begin.
The first network type we're going to discuss is a LAN, L-A-N. This stands for Local Area Network. A local area network is going to be a network that will reside within a single building. Within your office building, you will have a number of different devices that will connect to your network. These can include computer devices, desktop and laptop computers, printers, servers, storage drives, and other devices. A local area network is when we can connect all of the different devices within our building's infrastructure network to communicate with each other and send and receive data communications. A local area network can operate either with a wired Ethernet or a wireless network connection. Our Ethernet networks are standardized through IEEE 802.3 Ethernet cabling. With wireless networks, we follow the 802.11 wireless standards. There are several different LAN topologies or structures that you can see, including ring, where all of the devices will connect to each other in a circular pattern, a bus topology, where all of our devices will connect to one single network cable, a mesh network, where all of the devices connect to each other, and a star topology, where you will have one central location for your devices such as servers and switches, and all of the other devices within the network will connect to it. Our next network type is a WAN, W-A-N. This is a wide area network. Wide area networks are ones that extend over large geographic areas. There are two common structures for wide area networks. One common type of WAN is when you have one organization that has multiple locations for office buildings or job sites. And all of your different locations will connect to each other, typically through fiber optic cabling, coaxial cabling, or a wireless connection over 802.11 or satellites. Your wide area networks will typically have slower data transmission speeds than your local area networks. This is due to the longer distance that data must travel between locations. And the third network type to be aware of is a PAN, P-A-N. This is a personal area network. Personal area networks are network configurations that allow us to connect devices within a very short geographic area. We have discussed several types of personal area networks in previous episodes, and the three that you should be most familiar with are Bluetooth, infrared, and NFC, near field communication. Bluetooth is a wireless personal area network connection that we use to pair or connect two Bluetooth compatible devices. We commonly use Bluetooth to connect peripheral devices to computers, such as keyboards and mice. We also can use Bluetooth to connect our computer devices to things such as external speakers. Infrared is a common PAN network type that we see in our home entertainment centers. If you use any type of remote control to manage your digital televisions or home entertainment systems, your remote controls use infrared technology to communicate data. The third type is NFC, near field communication. This is a wireless connection that we use for very short distances. The most common use case for NFC is for mobile payments. If you use any type of payment service such as Apple Pay, Google Pay, or others, and you use your mobile phone to complete a transaction at a point of sale, this is using NFC technology. Next, we're going to discuss two common addressing schemes that we use in networking. These are IP addresses and MAC addresses. An IP address, the IP stands for Internet Protocol. IP addresses are numerical labels that we assign to devices that connect to a computer network. There are two types of IP addresses, IP version 4 and IP version 6. IP version 4 addresses use binary decimal notation. They contain 4 different sections of 8 individual bits. A full IP version 4 address will have 32 bits or 4 individual bytes. Remember, 8 bits equals 1 byte. And we use binary notation to calculate the different values in each section of an IPv4 address. The other type of IP address is IP version 6. This is an addressing scheme that uses hexadecimal notation. If you remember, hexadecimal notation is when we use the integers 0 through 9, as well as the letters A through F for numerical values 10 through 15. An IP version 6 address will have 8 different sections. In each section, you will have 16 bytes. A full IP version 6 address will have 16 bytes or 128 bits. You can distinguish an IP version 6 address because each section will be separated by a colon. We also have MAC addresses. MAC, or MAC, stands for Media Access Control. MAC addresses are unique identifiers that are assigned to the network interface cards for our connected devices. A MAC address will be 6 individual pairs of hexadecimal digits. And a MAC address will use periods or colons to separate each segment. Within a MAC address, there are 2 different sections. The first half of a MAC address is what we call the OUI, the Organizational Unique Identifier. This will be the MAC address segment that will contain the vendor identification for distributed MAC addresses. The second part of a MAC address is the NIC. This is the Network Interface Controller. This is the segment that we use to locate each individual device on our network. Now we're going to discuss some common protocols and services that you should be aware of in basic networking. The first networking service we're going to discuss is DNS, the Domain Name System. DNS is a very important networking service because it allows us to translate domain names into their numerical IP addresses. When you go online and you open up an internet browser, in the address bar at the top, you will type in what's called a web address. And your web address will be the name of the website that an organization uses online. But DNS will translate the typed domain name into its IP address. We use IP addresses with all of our online websites so that networking devices can identify them from their numerical identifier. With DNS, we will have server devices. These will be standalone devices that will keep records of all of the different web searches that our users conduct while they are connected to our network. And within the DNS server, it will keep records of the corresponding IP address that is assigned to each website that our users access. We also can do reverse DNS. This is where we can type in the IP address of a website, and our DNS server can return the domain name for that specific IP address. Our next network service is the HTTP protocol. HTTP stands for Hypertext Transfer Protocol. HTTP is the protocol we use for all of our website traffic. A user can access websites by typing in the domain name, and we use the HTTP protocol to return all of the different files, images, and graphics that are contained within the website online. We have another form called HTTPS. The S stands for secure. With HTTPS, all of our internet traffic will be encrypted. This will prevent unauthorized users and hackers from being able to view the data that is being sent through all of our HTTP requests. The HTTP protocol uses two different port numbers. Standard HTTP uses TCP port 80, and HTTPS uses TCP port 443. Next, we're going to discuss three different protocols that we use for email. Our first is POP3. This stands for Post Office Protocol version 3. POP3 is a protocol that allows us to retrieve emails from a server and download them to our device. POP3 will require authentication. This means that a user must enter in a username and password to be able to access our email servers. Once a user downloads an email message from the server to their local device, the message will be deleted from the email server. POP3 uses TCP port 110 for its email retrieval. Another type of email retrieval protocol is IMAP. IMAP stands for the Internet Message Access Protocol. There are several different versions of IMAP. The most recent is version 4. IMAP is another protocol that we use to retrieve emails that are stored on a central server. One feature of IMAP that is very helpful is the ability to search messages by folders, directories, and server indexing. IMAP will also require authentication. Typically, this will be the name of the IMAP server, as well as the individual user's password and username. IMAP uses TCP port 143 for its email retrieval. Our third email protocol is SMTP, the Simple Mail Transfer Protocol. This is the protocol we use to send email messages from our devices to other servers or users on other networks. SMTP is the protocol that we use in our standard email systems, such as Google's Gmail, Microsoft's Outlook, Yahoo Mail, and others. SMTP does not use authentication features. It relies on the device to require the appropriate authentication to identify our authorized users. Once a user is authenticated to a device, then the different email systems that are available can be accessed through an internet connection. SMTP uses TCP port 25 to transmit all of our email messages. Our first networking device is a modem. Modems are hardware devices that allow us to convert data from one format to another. There are two types of modems that you will find: analog and cable. An analog modem is one that will translate data that is sent over our traditional copper telephone lines. Analog modems allow us to convert the data signals from the analog telephone lines into an analog signal we can use in a wired or wireless network within our home or office. Analog modems typically operate in kilobyte per second speeds. Cable modems, which are more common, allow us to transmit digital signals from either coaxial cabling or fiber optic cabling into a workable data signal for wired Ethernet or 802.11 wireless. Your cable modems will have interfaces on the back of the device that allow you to connect Ethernet cables or wireless access points, so that once the signal is translated from coaxial or fiber optic cabling, we can then translate that signal into one that works within our home and office environment. Your cable modems will typically operate in a megabit per second and higher data throughput speed. Our next networking device is a switch. Switches are devices that we use in our local area networks. Remember, we said that a local area network is one where all of our connected devices will reside within a single building. Switches allow all of the connected network devices to communicate with each other. A switch is a hardware device that will have rows of interface slots that allow us to connect Ethernet cabling as well as certain types of fiber optics. If you have multiple user computers within your office, you can connect all of those devices to a single switch by using cables that will be laid from the location of the device to the switch. Switches will allow all of the different devices to communicate and send traffic from one device to another in our local area network by using the MAC addresses. Remember, a MAC address is going to be the identifier that is contained on the network interface card for all of our connected devices. And our switches will keep an updated table for the MAC addresses for all of our network devices so that we can send and receive data within our local area networks. Our next networking device is a router. A router is a hardware device that allows our local area network to connect to other networks outside of our building. Routers are able to send and receive traffic using IP addresses. When we want to send a data request from our local area network to some website or location outside on the public internet, we do so through our router. Our data packets are forwarded from the local area network to our router, and the router will sit on the perimeter of our local area network. And it is the device that will send and receive data from outside networks. Your router devices keep a configuration called a routing table. The routing table will be an updated list and database for all of the different IP addresses that data is sent to and from on our network. Next on our device list is a wireless access point. You commonly will see this abbreviated as WAP. A wireless access point is a hardware device that allows us to convert a wired Ethernet connection to a wireless connection for our user devices. Your wireless access points will typically be configured on your ceilings or high on your walls throughout your building. And your network access point will connect to a switch through a wired Ethernet cabling. And then what we can do is once the wireless access point is connected to our switch, all of our users can then connect to our network over a wireless 802.11 signal. Wireless access points are able to forward data through MAC addresses, the same way that we do with our switches. And finally, we have a firewall. Firewall is a very important networking device because it allows us to add security to the types of data traffic that comes in and out of our local area networks. Our firewalls allow us to monitor and create filtering rules to allow or deny certain types of traffic. So for example, with a firewall, we can configure rules to allow only certain types of web traffic. We can also block access to certain types of websites or certain types of applications. With firewalls, we have the ability to create traffic rules based on IP addresses of websites, application types, as well as individual port numbers where certain types of traffic will travel to and from.
That will conclude our discussion of Section 2.8 Networking Basics. In our next episode, we will move on to Section 2.9 in the objectives, and our topic will be small wireless networks. We thank you again for following along in the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your day.